So our next speaker is Job Snijders from NTT Communications. Job is very kind visiting us from the Netherlands today, and he will tell us the latest news on the BGP side of the things, what's going on at ITF in the GROW or IDR working groups. And so he will summarize much of his work and other people's work for the past year. So, Job, the floor is yours.
Thank you, Paulo. My name is Job Snijders. I work for NTT Communications, a company with real courage. As you can see, we brought a McLaren to a Ferrari city. Before we start, it's important to emphasize how important Bologna is to Dutch people. Every Dutch supermarket carries original Bologna-tasting chips. But the weird thing is, apparently they have nothing to do whatsoever with Bologna, but this is how we recognize your cultural contributions to the world. Thank you for that. Okay, now to the serious topic, the battle of operations, as I like to call it. You may remember that last year I was standing here and I was talking about large communities, and I was a little bit angry about the lack of progression that ITF was making to make the life of network operators easier. And I have good news to report. In the last 12 months, a great deal of innovation was pushed through ITF. It was like a congestion that suddenly was resolved, and a floodgate of RFCs came out that make our life easier. And in this presentation, I will cover a number of those RFCs. You could view this presentation as 4 small presentations together. So at any point, if you have questions or are curious about something or would like a little bit more detail, just feel free to raise your hand and interrupt me, because that way we make sure that the questions are at the relevant and appropriate time rather than waiting for the end of it. A little bit of background. The IETF, the Internet Engineering Task Force, is the standards body that governs things like BGP. And it is really, really important that we have this standards body so that all of us speak the same flavor of BGP. Without a standardization body, it would not be possible to build the internet as we know it today. And within the IETF, there are 2 working groups that are relevant. There is IDR, which stands for Interdomain Routing, and there is GROW, which is Global Routing Operations. And IDR people create the protocol, and the GROW people are like the customer advisory board. They give feedback on how to use the protocol. So this is really an important distinction, that you have creators of the protocol and users of the protocol, and both groups help progress and innovate on BGP. If you want to participate in the IETF, I have great news. It is free of charge. So that's why a lot of Dutch people are involved. All right, the agenda for today. I'm going to cover a safety RFC, 8212. Let me cheat a little bit by looking at the screen. We'll cover some performance-related RFCs that prevent packet loss. We'll talk about coordination between network operations centers, so from NOC to NOC communication, and we'll highlight a little bit of large communities or network management. This is a very recent RFC, 8212, and it describes the default behavior of eBGP speakers. As you can see, this is a photograph of a route leak, and we were tired of those. And one of the things we can do about route leaks is go to the source of the problem and try and define how BGP speakers should operate with each other, what their behavior should be. So, a small puzzle. If you look at this configuration, what does this configuration accomplish? 1 point for Marco. This is a minimal BGP configuration that works on Arista and Cisco iOS on Brocade. And it looks very innocent. It looks like, you know, let's bring up 2 BGP sessions with 2 transit providers and that's it. But what it does in reality is it opens the floodgates between the 2 sessions that were brought up. Because unfortunately, many BGP implementations these days, by default, will announce everything they know and accept everything they know. So these 5 lines can bring down entire societies, and this happens every so often. So what does this RFC that I've been mentioning, A212, actually do? I think a great analogy is that it's like airbags in a car. It's a safety mechanism built into the device itself, and when you need it, it kicks in. And what RFC A212 prescribes is that by default, a eBGP speaker should not exchange routes. So if we go back to this example, wait, I have a better example here. The RFC describes that implicitly, if no other BGP policy is associated with the BGP neighbors, a deny all filtering policy should be applied. And this is of great advantage to all of us because it means that the moment you copy-paste a snippet of configuration, and for whatever reason you only manage to copy-paste half of it, because maybe your cell phone connection cuts out, maybe something else happens, and you cannot get to the point of copy-pasting the portion that actually associates a filter with the session. In the old world, you'd be leaking everywhere. In the new world, the device should protect you and not do any eBGP route exchange until you explicitly configure it to do otherwise. So this, in a nutshell, is RFC A212. Now, it turns out that once you write an RFC and get it published, not all the world's routers are automatically upgraded and compliant with these new standards. It turns out that publishing an RFC is only a small part of the whole process. So for this reason, I urge all of you, when you talk to your vendors, this is one of the safety mechanisms you'll want to bring up on your RFPs and mandate that your vendor protects you against accidental misconfigurations. This not only benefits you as an operator, but it also benefits your BGP neighbors who no longer have to suffer through route leaks caused by incomplete configurations. Why this RFC came into being and why it only applies to eBGP is because eBGP should be viewed as a shared resource. It is something all of us have in common. It is how we reach each other. It's a bit like the environment. And if we don't all properly take care of this, it affects all of us. I mean, a small route leak in one ASN can actually disrupt services on the other side of the planet. And that's why documents like these, in my opinion, are of crucial importance because all of us benefit by mandating this from the vendors. Another advantage of this RFC is that the behavior of BGP speakers on different platforms is different. For instance, BERT will not announce routes, but accept all routes by default. Cisco iOS accepts all routes, announces all routes by default. Cisco iOS XR does not exchange routes by default. And this is not helpful. If you have an inconsistent experience across multiple vendors, it can only lead to trouble. And this document standardizes the one true way that a eBGP speaker should behave. And of course, on iBGP, very different considerations apply. You have different services, there's a layer 3 VPNs, there is this, there is that. So this document is only meant to specify how it should be for internet. And that's why it's eBGP specific, because iBGP is an entire different beast. We're keeping track on GitHub, github.com/bgp/rfc8212, to keep track of how the vendors are behaving. Some of the vendors have indicated that they will change their behavior. One of those is Nokia, and I applaud them for their courage to break a default setting of the past and realize that secure fail close default is a better approach and beneficial for the customers. But of course, there are many other vendors in the field, and all of them need encouragement from their customers, need encouragement in the form of saying, if you want my money, in return, I want you to have sane and safe default behavior. So I hope that in the coming years, we will be able to see progression and more and more adoption of good default behavior. You, as an operator, should not only be reaching out to your vendors, but there also is an aspect internal to your operations. Because we know that different vendors have different behavior, and that we know that some vendors are changing their behavior over time and flipping the defaults, it'd be really good in your labs and quality assurance departments to verify that each and every software release does what you expect it to do. And one very good approach is to look in your network for reliance on implicit behavior. If you have BGP sessions that rely on no policy being configured and then certain behavior associated with that policy, or with the lack of that policy, it'd be good to convert all of those into explicit configuration. So on an iOS CPE, where you, for instance, just want to accept all routes, do not rely on the implicit behavior, but configure it explicitly to accept all routes, and make sure that you test for this. This is useful because it makes your configurations more readable, and it future-proofs you if over a software release things change. Any questions so far on this specific topic? All right, everybody got their homework? Excellent. The next one, management. And of course, there's a good deal of overlap between last year's audience and this year's audience, but I'll briefly summarize what work has been done. About 11 years ago, 32-bit AS numbers were introduced because almost 2 decades ago, people foresaw that the internet would grow beyond 65,000 networks. And each autonomous system requires an autonomous system number, otherwise they cannot interact with each other. And we see that more and more businesses are getting their own network to ensure their independency, to ensure that they have agency, that they can buy from multiple providers, that they can peer with each other on the local internet exchanges. All of this is extremely healthy and a sign of a growing ecosystem. But this ecosystem was bound by 16-bit ASNs, and that's why the IDR people set out to update the protocol and allow for 32-bit ASNs. And that would allow the network to grow to close to 4 billion networks. All of this was great, except one small oversight happened. BGP communities were not updated in a similar way. And the strange thing with BGP communities is that they are 32-bit values, of which the first 16 bits is the AS number, and the last 16 bits is whatever you as network operator decided to be. And you can see how having a 32-bit AS number and a 16-bit field can lead to problems. It simply doesn't fit. Unfortunately, it took many, many years of arguing in IETF to find a solution to this seemingly simple problem. And that was done in the form of large communities. Large communities was truly a grassroots effort where hundreds of operators showed up either to IETF or called their vendors, usually in an angry tone, and said, I want a solution to this 16-bit, 32-bit ASN community problem. I want large communities. And we succeeded. There are many implementations already today. This is one of the most well-received RFCs in recent times. And I really think this will help us grow the internet in the next 20 years or so. If you want to get started with large communities, there are a number of resources available to you. There is the largebgpcommunities.net website that has news and updates about vendors that have added support and internet exchanges that upgraded their route servers and other stories. There has been a ton of presentations that you can review. We have configuration examples at largebgpcommunities.net/examples. And we're keeping track of every BGP implementation that we know of. So if you use a particular vendor and you see on our website that they don't have support for large communities, email your vendor and demand that they upgrade their software to accommodate the new style of BGP communities as well. Any questions on large communities? Perfect. Now we'll bring some absolutely new content that was not here last year. We're going to cover the problem of coordination, or actually communication. I bet many of you have seen the messages on an internet exchange mailing list where somebody emails, I am going to do maintenance on my router. And then someone else emails, well, what's your circuit ID? And then someone else emails, why are all these robots emailing me? And then chaos ensues. And this happens everywhere around the globe. And the larger the internet exchange, the more noise there is on the mailing lists about maintenance. And of course, I appreciate that people actually announce that they're going down. This is useful information. But in a strange way, it's kind of convoluted to announce to a large audience that you're doing maintenance if you're maybe only peering with, say, 25% of that audience. So if we look at the BGP protocol, there used to be no mechanism to tell other people why a session goes down. You can only, if you shut the session, the other guy sees the session is down and has no idea why. So we've experimented a little bit with various methods to communicate through BGP. In this image, I attempted to convey the message of the Nyan cat, and I did this by flapping 200/24s in a particular order, and that would paint the image of the Nyan cat on RIPE's BGP analysis web interface. This is a great method of communication because you can really add depth to your message. The downside is that it takes roughly 6 months per image to pass on. So I don't think this is the way forward for NOC-to-NOC communication. I introduced to you the BGP administrative shutdown communication. The trick with the BGP shutdown communication is that you embed a small message inside the BGP message that triggers a session teardown. The message can be up to 128 bytes, and it supports UTF-8, so you can now officially transport emojis over BGP. But the usual use case will be that, for instance, if this network is going to do maintenance, they shut down the session, and in shutting down the session, they can add to the shutdown command a small sentence that will show up on the other side's syslog. And in this example, we pass on a ticket number and a brief description where we say, software upgrade back in 2 hours. And then this network, when they see the session go down, they see that traffic is disappearing, and they look at their syslog, they not only see the session is down, but they also see that message, "We'll be back in 2 hours." And perhaps an announcement was sent ahead of time, and they can punch in this ticket number in their email system, and it just pulls up all the data and etc. And this should be a time saver for all networks involved. So some users guidelines. When you shut down a session and you're going away for a period of time, make sure to, if your software supports it, to include such a message and inform your neighbors what type of work you're performing and when you'll be back. On the receiver side, it'd be good if you have syslog analyzer software that you work with the analyzer software company, or if it's your own homegrown scripts, that you start looking for these shutdown communication messages and add those to the internal tickets that you may have. And I think it would be beneficial if you always try and include a reference to an emailed notification, because of course in 128 bytes you can only fit so much data, so the bigger story should be done through other out-of-band mechanisms. This is one example of OpenBGPD, the software on OpenBSD. There is a command called BGP CTL, or BGP control, neighbor IP address down. That's the command that was always used to shut down BGP sessions. But what's new is that I can add a freeform message after that, and that freeform message is packed in the BGP cease notification, transported across the BGP session to the other side, and on the other side, in syslog, you see not only that the neighbor has shut down the session, but also the message that the neighbor gave. In terms of implementation, the open source world is, again, leading the innovation. There is a partial patch for BERT, but it's not yet finished. Cisco iOS XR has a beta image that supports this. PMACCT, of course, supports this. OpenBSD supports this, Quagga supports it, GoBGP. There's also decoders like TCP dump and Wireshark, so that when you're sniffing a BGP session and this trick is used, that you can also see it. But the list is far from complete. Again, if you think this is useful, please talk to your vendors and ask them, hey guys, we want a shutdown communication feature. In terms of code complexity, this is a really, really easy feature. It's a few hundred lines in most of the open source projects, and I think in the commercial implementations, it's at best a few thousand lines. This is not a big feature. It's not intrusive. It fits really nice in the existing BGP framework. So it's a no-brainer for most people to implement this. All right.
Do you think it would cause any problems with name? I'm Paolo from Telemar. It's a small ISP.
Hi.
Can't this cause any problems with all the implementation of BGP? Did you test it from all the?
Yes, of course, we tested this in production. No, a more serious answer. The beauty of the way this was designed is that it's fully backwards compatible. Already, the BGP RFCs allowed for, let's call it trailing garbage in that particular BGP message type, and the use of those bytes that could follow was just undefined. So some of the implementations ignored it, which is fine. Some implementations would print a hex dump in syslog, that's also fine. And what we've done is we've repurposed that portion where garbage could exist, and we said, well, it's no longer garbage, it's the shutdown communication. And another aspect is, if this crashes the BGP session, whatever, we were already going down. We were shutting down the BGP session to begin with, so there is very little problems that could arise in that aspect as well. So that's why this one is that's why I call this one easy, because it really fits in with what already exists, what already is done in the wild, and what already, where BGP speakers already should be robust. And that's why this was easy and not if this would have been a new BGP message type, then there would be many, many more considerations, and this would have been a multi-year project. But since we're recycling everything, it's simpler.
Thank you.
Earlier I said that it's a 128 byte long message, and the reason we limited the length of this message is to prevent what I call visual spoofing in the syslog. Right now you can see that this syslog message is very concise, and you can clearly see that it's one line. But if we had allowed an unlimited message, you would have been able to fill the syslog with a single message that visually looks as if it's many messages. And for instance, this may trick people into doing emergency maintenance. And that's why
Marco Dietrich, CWeb. Are the current implementations actually smart enough to remove new lines from the messages?
The question is how to clean up garbage from messages. Garbage could be, say, new lines. So the beauty of UTF-8 is that we can now send poop emojis to each other. The downside of UTF-8 is that it allows infinite permutations of concepts like the new line character, or strange white spaces, or things that look as one thing but actually in the code are something else. And it is something for each implementation to decide how they will handle strange characters. Fortunately, syslog is a really old protocol, and many vendors have already, through trial and error and crashes, learned how to deal in a robust way with syslog messages. Some of the implementations just pass through the control characters and say this is the responsibility of the terminal. Other implementations try and flatten the message a little bit, but that's for the market to decide and not for the protocol to decide. In reality, if your implementation is not UTF-8 ready, I think you have bigger problems than this feature. There's many more countries in this world than just America, and I think it's important that we as a community recognize that there are many other character sets than 7-bit ASCII clean, and software will just need to grow up and deal with it. But since the session is already going down, if there are really problems, the session was being shut down anyway, so in my opinion, it's not even that relevant. So ask your vendors for support for the BGP chat function. All right. The next slides are about improving the performance of your network. And with performance, I'm not talking about speed, but about avoiding packet loss. There are two types of maintenance that we can recognize especially in the Internet Exchange landscape. There is the voluntary shutdown, where, for instance, I, as operator of a router, will upgrade my software, so I decide to shut down the BGP sessions and then proceed with my software upgrade. And then there is what we call involuntary shutdown, where the intermediate provider, for instance, an Internet Exchange, disrupts the BGP session to force rerouting of traffic flowing across that set of switches. We'll cover in more detail what that exactly means, because it's a relatively new trick. But of course, voluntary shutdown is something all of us are already doing for years. Now, with the voluntary shutdown, turns out there's one strange phenomena. When you shut down a session, it is not always as hitless as we want it to be. In fact, if you shut down a BGP session, in all kinds of BGP topologies, a little bit of black holing may be introduced. And this black holing may be milliseconds, or maybe it's seconds, or even worse. It really depends on the type of hardware that you have, how fast your router can reconverge, what alternative paths exist. So part of the problem is somewhat academic, but another part of the problem is that we cannot exclude that the black holing happens in our operational life. So what happens? Imagine that I am the orange router at the bottom of the screen. I have two BGP sessions with the blue network. And to both those, and I did this for resiliency purposes, and to both of those border routers of the blue network, I announce my prefix. The moment I shut down this BGP session, this ASBR, the Autonomous System Border Router, will generate what is called a withdraw message in BGP. So the session goes down, the BGP speaker removes the routing entries from its routing table because the session is down, and it propagates to the rest of the network, hey, this path no longer exists. It tells the route reflector the path no longer exists. The route reflector does best path calculation, ponies up a new path, and the new path could be the alternative via the left side, announces it back to the ASBR, and then the ASBR can install this path and start forwarding packets. But notice that between sending the withdraw and waiting for a new alternative path, in that period of time, there is no route. And that means black holing. And in some networks, this is, milliseconds. You don't even notice. But in other topologies, for instance, if you're dealing with PowerPC-driven routing engines, like on older Brocades, or you have the MX80 from Juniper, if you're really, really unlucky, and this was a BGP session with many, many routes, this can take a while. And that's a shame, of course, to throw packets on the floor. So graceful shutdown is the medicine against this type of problem. What happens with graceful shutdown is that here I am as the orange network, we have the blue network. When I want to shut down this BGP session, I first signal to the blue network, guys, take note, within the next few minutes, this path will disappear. So you better start looking for a new path right now, because a few minutes from now, there will be no path. And if you don't have an alternative path installed, you'll be blackholing. Of course, this is not how routers actually talk to each other. The routers don't speak English. What happens is the orange guy announces all his prefixes with a special, well-known BGP community. And that well-known BGP community is the universal signal that the path will disappear shortly. And what it does is, on this ASBR, when it sees this special well-known community, it's 65535:0, it lowers the local preference of that route as low as possible, to say 0. It announces to the route reflector that path with a new local preference 0. On the route reflector, best path hunting is triggered, and the alternative path via the left side maybe is, say, local preference 100, which is the default, or maybe it's even higher because it's a customer relation. But the route reflector will see that the path with the graceful shutdown community attached to it is no longer attractive, and it will offer as alternative to this area border, ASBR, the path via the left side. So the ASBR on this side can flip the pointer. Previously, it was sending traffic down this link because that was the shortest path. But then this link informs the ASBR by sending the graceful shutdown community. The path no longer is attractive. It informs the rest of the network. The network presents an alternative path, and they can flip the switch and without any packet loss, switch to the backup path. So once that has happened, then you can actually proceed and shut down the BGP session, unplug the cable, swap the optic, do your work. And this is really, really elegant because this really removes any possibility of black holing because you instruct the network ahead of the disruption to look for an alternative path. So compared to normal shutdown, the session goes down, then everybody is scrambling, oh, the session is down, where's the alternative path? And with graceful shutdown, ahead of time we plan, hey, what's the alternative path? Oh, we got an alternative path, now we can bring down the connection. There are two aspects to using graceful shutdown. One is you need to support receiving the BGP community and acting upon it. And the other aspect is that you actually send the community if you're going to do maintenance. In your eBGP policies, I would recommend everybody to include a small stanza that matches if this community is present on the prefix, then lower local preference to 0. That's all. It's really simple. On many implementations, it's only 2 or 3 lines of configuration. So that's the easy part. And then on the sending part, to make use of the feature that your neighbor is offering you, when you're going to bring down your sessions, first apply a routing policy that attaches the well-known community to all announcements. Wait a little bit for things to converge and alternative paths to be found, and then proceed and shut down the session, maybe even using the shutdown communication, and do your maintenance. And when you're done with your maintenance, then you remove the piece of the config that adds the well-known community to your announcements, and you just restore everything to how it used to be. So here are some configuration examples. This is iOS XR. If community matches any 65535:0, then set local preference 0. That's it. On iOS, Brocade, Arista, etc., it's also very simple. You define a community list that contains the well-known community, and on your eBGP in policies, you say match on the community G-shot, and if we have a match, set local preference to 0. And this is crazy, I think, that such a complex feature that triggers all kinds of behaviors that are good for our operations is only 2 lines of config in our routers. That's the type of complexity that I like. So, in a nutshell, when you see the graceful shutdown community, it means, hey guys, this path will disappear within the next period of time. Look for a better alternative path. And this phenomena has been picked up in the network operator community. There are many large carriers already today that support receiving the graceful shutdown community. NTT, GTT, GitHub, Nordunet, Telia is working on it. So this is a thing that many other networks are doing, and I would love it if I could add your networks to this list as well. And there's one curious thing. In the peering world, there is this dogma that you will never give traffic engineering features to your competitor. So if I'm peering as NTT with another carrier, we don't offer that carrier features like prepending and black holing and etc. Except for the graceful shutdown community. That is the exception we've made. We stated, the moment we peer with another network, apparently, we want to exchange packets with each other. Otherwise, why would we peer? And if we want to exchange packets with each other, it makes sense that we want to do so with as little packet loss as possible. So from a business perspective, I think it makes perfect sense to not only offer this to your customers, but also offer this to competitors you're having peering relationships with or others. Just apply this policy on every eBGP session you have in your network, because that way everybody benefits. So that covers graceful shutdown. Another aspect that is relatively new, and with new I mean it's only been around for a number of years, is called BGP session calling. Imagine on the left side, this is my network, this is your network, and in the middle we have an internet exchange. And the beauty of internet exchanges is that it aggregates all these different BGP sessions behind a single interface. It's a very efficient way to reach many networks. The downside is that our routers are no longer directly connected to each other with a physical cable. And what it means is that, for instance, if this cross-connect goes down, this interface stays up. And we rely on the BGP timeouts before it triggers rerouting. And if we're unlucky, that could be up to 180 seconds or 3 minutes. So what can internet exchanges do to improve the experience of maintenance done on the platform? And this is called BGP session calling. And it's a very strange trick, but it's highly effective. If the layer 2 network in the middle is going to do maintenance, for instance, they're going to upgrade the switch or one of the switches, what they can do is they can insert an ACL or ECHO access list or firewall filter, whatever you want to call it, that affects the BGP traffic flowing across the portion of the internet exchange where maintenance will happen. So from my perspective, I'm forwarding traffic, normal traffic like VoIP and games and etc. and content, but there's also BGP traffic on the same connection. And if we kill the BGP traffic, after 180 seconds, my router will see that the session's timed out. I will reroute and send it to alternative paths. But in the time that you killed BGP, the normal traffic is flowing without any impact. And this is, again, a sort of encourage the network to find alternative paths before actually disrupting the network we're dealing with. So let's run over this phrase slightly different. An internet exchange says we have one switch, and on this one switch we want to upgrade the software. The internet exchange emails all the participants announcing the maintenance. A percentage of the participants will faithfully put it in the agenda and ahead of time close down BGP sessions. But there will always be a portion of participants that ignore the notification and don't do anything with it. And that group of participants is still, of course, valuable to the internet exchange. But maybe they didn't receive the message in the proper department, maybe it got lost, maybe something happened, it doesn't matter. The internet exchange itself can proactively force rerouting of the traffic before the actual maintenance starts. So the internet exchange kills BGP traffic, normal traffic keeps flowing until the BGP timers time out. Then you will see normal traffic switching to other paths. All the traffic is drained from the internet exchange switch, and then you can proceed with the maintenance without having lost a single packet. Of course, when the maintenance on that switch is done, you remove the firewall rule that was killing BGP sessions. The sessions come back up, and traffic starts flowing again. So in effect, all internet exchanges can use the rest of the internet as the backup. I think that's great. There are a few recommendations. If you apply a firewall filter, make sure that it only affects port 179, which is BGP, and only affects packets where both the source and the destination IP address are part of the peering LAN prefix. Do not touch other traffic, because that's not your traffic to touch. Make sure that you just kill 179, and source and destination IPs have to be part of the Internet Exchange. And do the same for IPv6 as well. So, a summary of what I presented you as recent innovations. What you can use today. If you're a network operator, you can use graceful shutdown. Implement the policies in your network, encourage your peers and customers to do the same, everybody benefits. BGP session calling. Most internet exchanges have hardware that was produced in the last couple of years. A lot of those can do the type of filters that are necessary. As an internet exchange, consider adding BGP session calling to your procedure of maintenance. And what is partially available, large BGP communities, shutdown communication, and secure eBGP defaults. So for those three, please reach out to your vendors. Please ask them to support those RFCs. And this slide has the exact references that you can use in the RFPs. So, of course, this was a group effort. Earlier in the talk, I said that hundreds of operators showed up with pitchforks to get shit done. This is actually a sort of credit list. There are more than 100 people that have participated in these internet drafts to make sure that you and I can enjoy easy network operations. And if you're curious about why graceful shutdown works the way it does, there's all kinds of science papers that are many pages with small letters that go into all the details. So, this concludes my brief overview of 12 months of IETF work. Do we still have question time?
I think with one question, if there is anybody. No question for Job?
No questions? Well, I'm here all day, so if you want more details on something, come find me and we'll talk. Thank you.
Thanks very much, Job.